Okay, in this question here, I'm going to go through B1 or B3 2018. Okay, so I'm going to give this a miss. The horizontal and vertical coordinates for point A, B, C, D, E, and G defining the four planes are also given. Okay, so part A is draw the given plan and elevation of the intersecting planes. Alright, A, B, C and A, B, D. So the X coordinates are how far from the invertical plane a point is. The Y coordinates here are how far from the horizontal plane it is, and the Z coordinate is how far from the vertical plane it is. Okay, so we're going to draw a line here. Really, it can be anywhere on your sheet that you want. Okay, and this is our Y line. It's our datum line, it's an edge view of our n vertical plane. Right now, so point A, alright, is 145 from the YY line, okay, on the X value. Okay, now, so A is going to be in this area. It's not, it's going to be higher up. B is 210 away. Okay, what's C? You check what C is. It's 155. D, E is there need to do E, yes. Oh, E, we're at E. And then G, 175 from the YY line. Okay, now we're going to do their altitudes. Okay, so E has an altitude of 45. The middle coordinate is point E. Okay, G has an altitude of 125. D has an altitude of 10. So we're going up 10 from the XY line. Okay, C has an altitude of 100. Okay, B has an altitude of 35. Okay, and A is an altitude of 60. So the question says draw the given elevation and plan of planes A, B, C. So I can join A to B, A to C, and C to B. Okay, and then A, B, D, E. So A to B, B to D, D to E, and E to A. So that's the elevation of that those planes just drawn there. Now we have to draw the plan view of those planes. So we're going to look at the Z coordinates, how far they're out from the vertical plane, which basically the XY line is an edge view of the vertical plane in plan. So to draw it out, it's how far down from your XY line in layman's terms. Now, so A is 45 from the XY line. So there's point A in plan. Okay, now B, what's the distance down for B? B is 80 from the XY line. C, try and figure these out yourself, you know which ones they are if you can. If you're watching this video, you may be a bit stuck on this part. C is 75. Okay, and then D and E. I have to do D. So D is a distance of 105 down from the XY line, which you won't see on my visualizer, at the moment. Okay, so I'll have to move it now in just a second, and then E is 60 down then from the XY line, and then while I'm here I may do G is 10 there down from the XY line. Okay, now ABC, so we can join ABC and then ABDE, so B to D, D to E, E to A. Okay, and I'll move the visualizer here. So there's the plan elevation of those there. So that's taken approximately 5 minutes. Now we have to find the dihedral angle between the two intersecting surfaces. So what you need to do is look along the line of intersection in real life, which is the line AB. It's the common one between the two planes, and see that as a point. So if you want to see a line as a point, you have to look along the true length of that line. Now in order to do that, you want to check to see, do you have your line of intersection already as a point? And line AB, or do you already have your line of intersection as a true length? And line AB is not a true length in any of the views because it is not parallel to the X or XY line in either of them. So I'm going to look perpendicular to line AB, so I'll just project it up here. I haven't got much space here on my sheet. I'm going to actually go downwards, so I am. Alright, so I'll move the visualizer again. So my set square lined up with line AB. I'll slide it down here. X1, Y1 line. Okay, projection lines perpendicular to your X1, Y1 line. Take your heights then from elevation. So using your compass, take the heights of the points from elevation. So you put your compass on the XY line. So if I want D, compass on the XY line, bring the nib to D, lift, find D and plan, mark it in there as you know yourself. Okay, let's move it down. I'll just move the visualizer down a bit. Okay, now C1, D1, E1, A1, excuse any noise now here, B1. Now A1 to B1, B1 to C1, C1 to A1. Guys, Guys, will you close the door there for me?
Sorry?
Will you close the door there for me, please? Thanks. Okay. Now, then, B1 to D1, D1 to E1, okay, E1 to A1. Okay, and there's them as two edges. Now, we need to see the line of intersection as a point, and this is the true length. So we look along its true length here. Alright, so we line up our set square here with the true length, one against it, and we slide now and draw our lines parallel the x1, y1 line. Right, here it is there. And then you draw your x2, y2 lines perpendicular to them. Now, you always take your distances for an auxiliary plan. If you projected your auxiliary plan off an auxiliary elevation, you take your distances from your x1, y1 line back, essentially two views. Right, now, so we're going to take our compass here, put our compass on the x1, y1 line, take the length of D from the x1, y1 line back, find D over here, follow it along, mark it in. Same with E. Lift, find E, follow it along, E there, A and B now, the compass on the x1, y1 line, back to A and B and plan, lift, find A there, A, say B, get you the same thing again. Now C needs to be done, lift, find C, follow C all the way over here, and then after just mark it in. So there's C1. Now C2. That's B2 slash A2. Okay, E2. Okay, and D2. Now we join these points together, and they should form a straight line, okay, which they do. So that's an edge view of this surface here, ABDE, and then join the line, the point view of the line intersection over there. There's the angle, right, your dihedral angle. Get your protractor, all right, measure the angle, write it in just in case you lose any marks. It only takes 2 seconds to measure it. And it could save you, particularly in a short question, it could save you up to 8 marks. So the angle there is 100. Okay, 100 degrees. Right, now that's part B done. Now the next part is draw the elevation and plan of point G and determine the distance between point G and B. Alright, the opposite edges AE and GF of surfaces AEFG are parallel. So A to E, okay, A to E is parallel to G to F. Alright, so A to E is parallel to G to F. Okay, and then F to E is a vertical line here. Alright, and you know it's a vertical line in plan, alright, on your page, because if you have 2 points in, if you have a point in elevation, its position in plan is directly below. So if those 2 points are on the same line, a vertical line elevation, they have to be on the same vertical line on your sheet in plan. So now, so we have, I'll go back here. So we have to complete the elevation of, you can't see that. You have to complete the elevation and plan of surfaces AEFG and ACG. Now parallel lines are parallel in every orthographic view. Alright, now, so getting point G in elevation is pretty straightforward, alright, as we've gone through. Now, we have what you call it, A to E in elevation, so we're going to just put our set square on A to E, slide it up here, okay, bring it to G and draw in a line here, and then we know it's a vertical line there. So we can draw a vertical line there from E there to establish point F. Okay, now we can heavy in that detail while we're here. Now there are different ways to establish point, G and point G and F, alright, in plan. Now we know G is here, okay, in plan view, and we know G joins to A, alright, so we're going to join G to A. And as we know, or as we learned in the last one, alright, A to E is parallel to line G to F, and parallel lines are parallel in every orthographic view. So line up your set square with AT in plan, slide your set square onwards and bring that down there, and where it intersects is point F. And then, okay, go on ahead then and do your heavy and hidden detail, alright, in plan. So I'll just go along there. You have your question sheet to help show you which is which. Right, now that's that done. Now next part, determine the projections of a horizontal line drawn from C which will touch plane AEFG at a point which is 5 millimeters from C. Hence determine and indicate in degrees the true angle between this horizontal line and the vertical plane. Alright, so in order to see the true angle between a line and a plane, you need to see the line as a true length and the plane as an edge. Now, okay, so it says it has to be horizontal. Alright, so from point C, we're going to draw a horizontal line there until it touches, what does it say there, plane AEFG. So until it touches this one here. Alright, now remember this is going from point C. Now it doesn't you don't know that it touches F from there. We need to see this we need to see this surface AEFG as an edge. Alright, and we need to see that plane as a point. So I'm going to draw a line here across. I'm going to pick any point there, right, just up there, and I'm going to draw a horizontal line there until it pierces line GF. And I'm going to drop this down in plan until it pierces line GF again, and I'm going to drop this line down here until it hits line G to A. Okay, so this line here now is a true length, right, in plan. So I want to see this plane as an edge. Okay, plane A, E, F, G. And the reason I want to see plane A, E, F, G is so I can see where the line from point C intersects the plane E, F, G. So I'm going to look along this line here, that's the true length. Okay, projecting. Okay, points A, E, and G, and my X1, Y1 line in there. My X1, Y1 line. I'm taking the distances from my elevation. Quality of the visualizer is just dropped there. Okay, now, so I'm taking the distances from my XY line to elevation. So there's point F I'm taking, and I forgot to project F. So I'll do that now. I'm going as quick as I can. Okay, I know I'm at 21 minutes here. Okay, put my compass there for F on that. Okay, E, A, and then G there. So this whole surface needs to project as a line. Okay. Right, now, so we can join these together. If there's any points slightly off, like my one there is a bit off, point F, just join them as a line. See, my point F there is a tad off. Check it again there. Yeah, so it's like 2 mil off, so it should have been there. Now I also need to do point C. So I'm going to draw a line there from point C, okay, and parallel to the projection lines, and it says which will touch the plane AGEF at a point that is 55 millimeters from C, and it's a horizontal line. Okay, so that means it has to be horizontal in any auxiliary, and there's the altitude of point C. Continue on my X1, Y1 line, mark it in here. Oh, sweet. C1, okay, has to be horizontal, so it has to be parallel to the X1, Y1 line. That is 55 millimeters from point C. Oh, I'm a bit off there, so just give us one moment there. Now, it's not going to be a true length here because you're not looking perpendicular to it, but that's the point of intersection. Right, now you bring this, what you call it, back here. So you do. And now, right, what we have to do now is draw line from C, and it said which will touch the plane at a point 55 meters from C. Okay, so we're going to swing, we're going to take our compass, we're going to set it to radius 55, and we're going to put it here on C. We're going to swing it until we pierce our point right here, because that's the true length of 55. So that's his point of intersection, and then straight up here, it's there in elevation, that's his point of intersection, and then the true angle here is this here. And I noticed I forgot to do something in one of the parts. That's the true angle there, so whatever that is, which is, it's a 65 degrees. Now I forgot, it said to find the true length of line GB in part C. Alright, so it says determine the distance between points G and B. Right, so what you would have to do is join G to B, okay, draw a line parallel to the XY line in elevation, rotate it onto this parallel line, so point G isn't moving but B is, bring the line up here, bring point B across, okay, and then join it to point G, and that's the true length there of line G to B. Bit hard to see that on the video. Right, cheers, thank you, bye bye.